this lesson, I think this was hole punched out of your packet, by the way. This is 7.1. This is the last chapter that we're doing before we just start reviewing for the AP test. But 7.1, we're going to do some today, some tomorrow, and then we're going to spend all of next week on 7.2, which is the rest of this packet. Okay? I'm just going to kind of start this lesson today, finish it tomorrow. We're finding the area of the region between two curves. So in other words, we're finding this area right here. Does anybody have any idea of what we could do to find this? So we can use the two curves. And what do we need to do with those two curves?
Oh, like find the limit sum of the first curve and then of the second and just
subtract them. Okay, and we're not even going to do Riemann sum. We can actually do the real integral. So guys, those of you who are like, I didn't really know how to start this, when I give you some brainstorm time, think about this. The integral from a to b of f of x, wouldn't that be all of this area? Everything underneath, all the way down to the x-axis. Do y'all see this?
like all of it.
That would be the area of everything underneath f of x. But I don't want everything under f of x. Okay, so think of this. This area that I'm going to cover in blue, what is this integral? It's the integral of g of x. So I want to subtract that out. And then I'm going to put a dx at the end. You see what I mean? I want to subtract. Oh, I have too big of a, that's okay. My erase bubble is too big. If you understand this concept, it really makes what we're doing easier, I think, to understand, because it's not about memorizing one more thing. It's just about using what we know about integration. So if you want to find the area between two curves, you're going to integrate from the left point, x value, to the right value, okay, in other words, like this. And then you're going to take the top curve minus the bottom curve. What would happen if you accidentally mixed up the top and the bottom? What do you think how would that affect your answer? It would be negative. And we know that area is positive, okay? An integral can be negative, but area itself is always positive. We're actually going to skip example 2 for now. I want you to turn and look at this next page. These are some questions that some of them we're going to do together. One we're going to do together right now. A couple we're going to do together tomorrow. And then that'll be the rest will be for you to do for homework. So when you're actually getting to a problem, you're not always given the graph. Okay? Sometimes you have to graph it. So how do you guys feel about graphing y equals x plus 1?
Good.
You should feel good. It's a line. And how many years have you been graphing lines? A lot. Okay, at least since 8th grade. All right, for most of you. Okay, so y equals x plus 1, and let's go ahead and label it. Y equals x plus 1. Okay, what shape does the next thing make? A parabola. What are the transformations on this parabola?
It's flipped over the x-axis.
So it's upside down.
And it's shifted 9.
It's shifted 9 units up. Okay, now let's just pretend you didn't know that. Okay, or maybe you're like, I didn't know that. Okay, I forgot that. What you could always do is just plug in an x value and get a y value. So like if you plug 0 in, you would get 9. What happens when you plug 1 in? What's 9 minus 1 squared? 8. And the same thing you get with negative 1. What happens when you plug 2 in?
You get 5.
You get 5. And so negative 2, same thing. And when you plug 3 in, you would get 0. Okay? So whether you do this with transformations or just plugging points in, it's still important that you understand that this is a parabola. That's always going to help you. All right, and then we're going to go ahead and label this as well so we make sure we know which one's which. Okay, I'm going to do this other one in a different color. What type of lines are those?
Just asymptotes, maybe?
we think?
Second up and down.
Out of all the stuff y'all said, which one sounds right now that you're like, oh yeah? Yeah, they're vertical lines. Here's the deal. If you forget this, just think, this is the line where every single x value is -1. So everywhere x is -1, see, that makes a vertical line. If you just connect all those points together. Okay, so what type of line is x equals 2? Vertical, oh yay. It's easy to get that mixed up. It happens to the best students. You got to be careful not to make those horizontal lines. It's really going to affect, it's going to make your answer wrong, but a lot of times it makes it more difficult. All right, so what I'm going to do now is I'm going to shade. So if you're doing this with a pencil, I want you to just kind of lightly shade the inside. If you are have a highlighter or something and you want to do that, that's cool too. That is the area that we are going to find. It's the area that is blocked in by all of those things. Okay, I want you to quickly count up the squares and write an estimate of what the area you think is. And then we're going to kind of compare our answer to that. Just estimate by counting up the squares. Okay, and we're going to see at the end how close you were. All right, so we did number 1. Now number 2 says decide whether to integrate with respect to x or y. Let me tell you, the only thing we've done so far is with respect to x. So I want you to write that, with respect to x. This WRT is just short for with respect to. You can write it out if you want. The real reason I know, because I know how to do both, I know how to do more than what you guys know how to do, is I know it's with respect to x because see those equations? They're in terms of x. That's how I know it's with respect to x. If these were equations like x equals y squared, blah, 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 that would be with respect to y. Okay? Then it says to draw a typical approximating rectangle. What does rectangle make you think of? Riemann sum. We already said that kind of a little bit a second ago. All right, so I want you to draw anywhere on here you want a little rectangle. Because I really want you to understand the concept of what we're doing here. Because if you really understand the concept, you're going to remember it for a long time. We are going to, from -1 to 2, okay, we are going to find the area of each rectangle, and we're going to add them all up. That's how we're going to get the total area. Okay? This little approximating rectangle, you can draw more than one like I did, or you can just leave it at the 1. All right? The width of that is taken care of by the integral because we're going to go along each one, and we're kind of doing like infinitely many rectangles, okay? This is going to add up all of that. How would you find the height of that rectangle? The y values, okay? So the y value up at the top minus the y value at the bottom. So in general, the top curve, don't put the y equals here. Just put the 9 minus x squared. The top curve minus the bottom curve. Notice I'm going to use parentheses because I'm writing something more than just a single item after the minus. So no y equals. Notice that everything along here is in terms of x. X equals -1 to x equals 2. 9 minus x squared minus x plus 1 dx. When you're doing these problems with respect to x, everything's in x, and that's what we're used to. We're going to do it a different way in a minute, but just notice for now, everything's all about x's. Okay, now this says that we're going to find the area by integrating. Okay, I want you to do something really quick for me, which is I want you to clean this up. Okay, what is the easiest thing we could do to clean this up? Distribute the negative. So really this is -1. So what I'm going to do is I'm going to take the 9, I'm going to take the -1, and that's going to make 8. Okay, on the evens, we're going to get to use the calculator for that. But on the odds, we need to be able to do this by hand because not every problem do we get to use a calculator. So what is the antiderivative of 8? 8x. What's the antiderivative of x squared?
1/3x.
Some of you did not forget everything over spring break, which is great. It's easy to kind of forget little things. Integrating, not really a little thing, but. Okay, so that's the rest of that problem. Do you remember what you do next? Plug the top number in first. 8 times 2 minus 1/3 times 2 cubed minus 1/2 times 2 squared. I'm going to need to use a different line. Minus parenthesis, and then now we're going to write it again, but plug in -1. Okay, I want you, without a calculator, to crunch all these numbers. You're only going to have to do it this one time. In the future, I'm just going to let you box this and call that your final answer, but I want to get an actual answer and then we're going to check it with our calculator. I'll pull that back up. I just need to do this. So you're just crunching those numbers out. Your final answer should be a number.
Like a number.
It can be a decimal or a fraction, but a number. When you have found an answer, I want you to go ahead and check it by using your calculator to integrate. And remember, when you do this, you do comma x, comma -1, comma 2. Those of you that don't have a calculator, you're going to compare your answer to your estimate of what you counted up with the boxes. Okay. If you're still crunching numbers, just go ahead and look up here. I got 39/2. That's the answer. You could have gotten 19.5. What did you guys estimate when you counted up your boxes? Was it close to that? 19, 18? Good. Very good. Okay, so that is how you do it with your calculator and by hand. All right? I want you to turn back to the first page now, because I told you there's a whole, this is only going to work for half the problems. There's this whole other type of problem. And so I want you to, it's not that it's totally different, but there's some things we need to tweak. All right, look at this picture right here. Just based off the picture, how is this different than the ones that we just did?
It doesn't have any vertical.
There's no vertical lines on it. What else? It's a sideways parabola. Look, even if you try to get y by itself, you got to do a little bit of work here. By the way, we would square root, and you would get plus minus square root of 3 minus x. What this would mean is the top part of this parabola is the positive square root of 3 minus x. Okay, and the bottom part is the negative square root of 3 minus x. So I'm going to work this problem the same way we worked the other problem, and it's not at all going to be efficient, and you're not going to like it. And then I'm going to show you something else, and you're going to be like, okay, well, that's new, but it made that problem a lot easier. Okay? I want to explain to you why we can't just do every problem the way we just did them. Okay, if I try to make this problem work, look what happens here. If I want to find this area, okay, and I try to do it the way I did the others, look what's going to happen. I don't care if you write this down or not, but I want you to watch. If I try to say, okay, well, what is the left number? There's no vertical line, but I can still see that the left number is -1, right? What would be the right bound then?
3.
Okay. And then the top curve right here looks like it's x minus 1, but it's not the top curve for the whole thing. Do you guys see that? It's only the top curve to right there. Okay, so this is what I'm going to show you. Okay, I can find that, but that doesn't stop at 3. Where does it stop? Look at this right here. What's the x value where that stops? At 2. So I can do x minus 1 minus the bottom curve, but it's not going to find all of the area. We're missing this little piece right here. So the question is, well, how do we find that piece? Well, it's a different integral, and that's from 2 to 3. X equals 2 to x equals 3. The top, square root, positive square root of 3 minus x minus the bottom. Now, we've been running out of space here. Is this efficient or inefficient?
Inefficient.
It's pretty inefficient. Okay, if you plugged all of this into your calculator, you would get the right answer. I'm not even going to take any more time on that. Okay, what I want to do instead is think about this problem a different way. Okay, and I'm going to call this with respect to y. All right, now remember we had the equation, it was y squared equals 3 minus x. You see that y squared? That is going to be your hint next time that maybe this is a with respect to y problem. Maybe this is easier to solve it with respect to y. What you want to do is get x by itself. So remember, this was given to you. Y squared minus equals 3 minus x. That's that parabola, sideways parabola. If I just want to get x by itself, okay, I could add x to the other side, and I could subtract y squared. So this whole sideways parabola really can be represented by the equation x equals 3 minus y squared. Do you see how that's in terms of y? That's why we call it with respect to y, or in terms of y. This sideways parabola is x equals 3 minus y squared. Okay, but we got to do it for the line as well. The equation you had for the line was y equals x minus 1. What if we just got x by itself? What would that be? Because we got to be consistent here.
X equals y plus 1.
X equals y plus 1. So I'm even going to do this. Oh, no. This is y plus 1. That's what this line is. All right, so this is in terms of y, right? Everything's in terms of y, not in terms of x, which is weird. But once you get used to it, it's going to make this problem a lot better. Okay, now instead of going left to right, top minus bottom, we're going to switch all of that around. We're going to say, these limit numbers, these bounds, are going to be the bottom and the top. Okay, so what is the y value down here? At that point, I mean, I've just covered it up on the screen, but you see it on your paper. -2. Look, at this point right here, the y value, I'm going to switch colors, sorry. The y value is -2 at this point, at the bottom. What about at the top? We're not going left to right anymore. Remember, we're doing this in terms of y, so we got to go to the y values. So what is the y value up there? 1. Okay, so when we integrate, we're going to integrate from -2 to 1. The y values, not the x values. Remember, this is in terms of y. I need to use y values. All right, and this thing, and remember how before it was left to right, top minus bottom? What do you think we're going to do here? It seems like the top and the right have switched, and the bottom and the left have switched. So this is going to be right minus left. This whole idea of using these directional words, that helps some of you, and for some of you, you're like, that's actually more confusing. I don't like that. You don't have to use it. Okay? What you do have to know is that you are going to subtract your two equations. And which equation you put first, the only real thing that's going to, like, let's say you mix this up and you put y plus 1 minus 3y minus squared. How is that going to affect your final answer? Like if you switch the two up.
Change the sign.
Yeah, your final answer would be negative, but we want it to be positive. I get that some of you are like, hey, but that area is below. Okay, we're not talking about that. All right? The answer on these are always going to be positive because it's just area that we're finding. And so that's a good thing because it seems like everything else switches up a whole bunch. It's nice when something stays the same. If you switch these two things on accident, your answer is going to be negative and you're going to say, oh, I just switched them. Let me rewrite that and I know my answer is supposed to be positive. So it's easy to get it mixed up, but it's easy also to correct it. Okay, so one last thing. When we're doing with respect to y, the bounds are y values, bottom to top y values. The functions are in terms of y, and we have a dy. So everything's in terms of y. All right? You plug this into your calculator, you get 9/2. All right? And so I'm actually going to go ahead and do this just to make sure we're all good. So F3 integrate, we're going to go 3 minus y squared minus parenthesis y plus 1. Oh. Minus. Okay, after this, we're going to have comma y, comma -2, comma 1. And so, as you can tell, it's a lot easier when you get to use your calculator to do the integration. For most of these problems on the AP test, you get to use your calculator, so you're not having to integrate a whole bunch. Okay, I want you, though, to keep up on your integration skills because it's not always going to be a calculator problem. Okay? But that means you got to know how to use this 89. You got to know how to do the integration part, which I think you guys do. Okay. Down here, this kind of wraps up the two different types. I didn't do a rectangle. So the rectangle in this one, sorry I missed that, would look like this. In other words, from bottom to top, what we're doing is we're adding up the area of all of those rectangles. So my rectangle, my approximating rectangle, is going to be a horizontal one. As we move forward, you're not going to be drawing these rectangles every time. It's really just a way for you to really understand what we're doing, okay? So if you're like, I get everything but that rectangle, then you actually got everything. You're good. Okay, this is your homework for tonight. It's 5 problems out of the book. Okay, it's not due tomorrow. It's going to be due next week. Like by Monday, you should have this done.